Welcome to Nurse Science, everybody. We're going to start the Absorption and Radiation Lab, which in a normal year is a pretty big undertaking. We put it like a week and a half into this easy, even with the double periods. There's 3 sections to it. The lab's here in the background, and I'm using the laptop to record this, which will have some advantages and some disadvantages. So here's the premise. We want to see if I take a heat lamp here, a timer, and I put in front of it about 100 grams of sand and about 100 grams of water, and I turn this heat lamp on, how do these two things heat up differently? Do they heat up exactly the same, at the same pace, or is there a difference with how quickly they heat up? Hint, hint. If you've ever been to the beach, you pretty much know the concept behind this lab, because as you step onto the sand, if it's like in the middle of the day, what do you feel? And then what do? You go running towards the water. I mean, if the water were that hot on a given day, I think you would find it pretty bizarre, right? So we're basically going to put some numbers to that, and then also do it with black and shiny cans, and then also do it with a little greenhouse effect setup that we're going to see in a bit. Now, here's what it looks like in a normal year. Don't get intimidated yet. If you're here in a normal year, first off, there's this whole inquiry thing you do. You guys set up your own lab. You take your own notes. It's all of that. So you're getting out of all that. That's good news. Second, all of this data would be in your notebook. So you would have a data point for each of these every single minute for 30 minutes. And we're going to do it with the light on for 15 minutes and let these things heat up. Or the language we want to start to use is that they will be absorbing energy during that time. And then I'm going to remove the lamp, and we're going to let them radiate their energy for another 15 minutes. And that little thing right there is where really the key to a lot of this energy unit is going to lie. Everybody knows if I take the sand and I put it in front of a lamp and it heats up, yeah, we know that. Excuse me. And then if I take the lamp away, you all know it's going to cool off, right? But if we want to start looking at this through a nurse science lens, as we're going from seasons and thinking about the sun hitting our planet, as the sun hits Earth's surface, it heats up, yes. So that means Earth's surface is absorbing that energy. And then when the sun sets, Earth's surface cools down. But energy doesn't get destroyed in that process. That energy gets radiated back out of the planet. It doesn't just go away. If I had a beaker of sand that could make energy just go away, I'd be breaking the laws of physics, thermodynamics. And, we don't just destroy energy. If I had that beaker, I could make a lot of money, I suspect. So the premise is going to be now that I'm going to do all this. I'll be reading the times and all of that. Now, given that this is like doing a video and we're doing this in a COVID year, I think I'm going to cut the amount that we do here significantly. So what I'm going to do is, I think, a reading every 5 minutes. So when you hand in this lab, yes, there's going to be a lot of blanks. I would say that you're going to have a data points here, 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 and then, yeah, and then at 20, 25, and 30. Okay, so it's going to be a lot less. Also, using this laptop, what I'm going to do from time to time is I'm just going to press pause. There's no reason for us to sit here in silence for like 4 minutes waiting for it to go, right? I'll talk you through how it's going at the beginning, and then I'll pause it intermittently and just let time pass, pick it back up, say, here's where we're at. And all of that should sound good. All right. What do you think? Ready to go? And then, then we got to do this 3 more times. So get ready. This is a big chunk of class. You can do it. All right. So it's 0 minutes, which is basically now, right before the experiment even starts. And I've had these things sitting in my room getting balanced out for a little while. I'm going to get this to where I can read it without having to touch it. I'm going to go that our sand is at 20 degrees C. I should probably use the text box. And our water is at 19. All right. I don't know if I'm going to be typing those in. You might just have to listen to me and do it. I don't think I'm going to type them in the whole time because it's cumbersome. I'll leave that to you. But what we'll do, I want to make sure that these are lined up right in the middle so that they're getting an equal amount of sunlight. Make sure this thing's looking good. Quote unquote sunlight, lamplight, heat lamplight. All right, what do you think? Here we go. So I'll start. I got the lamp on. I'll show you what it looks like. Those two are going to slowly heat up for 15 minutes. And we'll do a reading every 5 minutes. All right. So let's talk about some of the things you're going to have to do. You'll get those numbers down here. I'll figure out what you got to do for the temperature axis. Once we see all the data, we'll figure out where we're at. Down here, there's 30 boxes for 30 minutes. So this is going to be nice and easy. If you start, why don't I make it a little bigger? If you start right at the origin at 0, that's going to be where we got those two pieces of starting data. And probably note that this is time in minutes. That's a good idea. Now, each one of these boxes is worth 1. I'll leave it up to you for how do you want to label that? Do you want to go through and label every one? Or do you want to do every 2? Or maybe every 5? I wouldn't say go by 3s. That's getting kind of weird, but 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, and so on. Do that, and it should be right to 30 at the very end. Allergies, I promise. I was tested yesterday. So do that, get that ready to go. And what this will look like in the end is you'll have 2 lines on there. You'll have to make a color key, do it your own way, where one will be for the sand and one will be for the water. And what they generally look like is that it heats up for about 15 minutes and then it cools down for about 15 minutes. What we're interested in, what the premise of the lab is how much does it heat up and cool down? So that's where these questions are going to come into effect. How much did the sand heat up in the first 15 minutes? Well, it started at 20. So if it goes to 21, it heated up by 1, right? It's going to be more than that. But that would be the idea. I don't want to know what it got to. I don't want to know that it got to 21. I want to know that it went up by this many. So it started at 20 and it went to what? Water started at 19 and it went to what? Then down here will be how much did they cool off in the last 15 minutes? So that's going to be where you take whatever it was at 15. That's your starting point. And then it cooled down to whatever this is in the last 50 minutes. So when it got to its peak, it's at this temperature. It cooled down by this much to get to that level. Not how much did it get to, not how much did it start at, but how much did it go down throughout the course of the experiment. Okay. So I think you guys will nail that. So we're at 3 minutes, 15 seconds. I think I'll pause here for a minute. I'll be back and we'll get our 5-minute reading. If it doesn't take 2 minutes for this, there we go. Quick pause. All right, we're back. Timer's at about 4:42, so we'll give it a couple seconds here. Just want to make sure I didn't go over. When it hits 5, I'll say the 2 temperatures. You're going to chuck them in those boxes, and we'll be good. 3, 2, 1. So our sand is at 25 degrees C, and our water is at 22 degrees C. So that's what you'll put in 5 minutes. And again, the other years we would do a data point every minute, but we're gonna make it short this year so that the videos are easier going. All right, why don't I pause again? I'll come back in about 10 minutes in the experiment. I'll be back. All right, we're coming up to the 10-minute mark. Hope everybody's doing okay. About 10 seconds. right, 57, 58, 59. All right, at 10 minutes, our sand is at 30 degrees C, and our water is at 26 degrees C. Then I'll be back at 15 minutes, and remember the premise then is going to be that we turn the lamp off and start to let these things radiate their energy. I'll be back. All right, it's just about time, 20 seconds. I'm going to point you at the setup here. Get blinded by the light. And at 15 minutes, I'm going to turn this off and remove it because it stays hot. It continues to radiate energy. Our sand made it to 35, and our water made it to 29. Sand 35, water 29. I guess I don't have to repeat. You're on YouTube. You can just rewind it. So now is the portion of the lab where we radiate for 15 minutes. Now on the lab, it's just like goes to minutes 16, 17, 18, 19, and so on, right? We're just going to keep on going time-wise. So now we're working on this bottom row of data. Your next data point at 20 minutes when I come back will be in there, and we'll see how much these things have cooled. And now the premise to remember and to build as we keep on working on this is that it's not just cooling, it's energy leaving those beakers and going back out into the room. If we could watch on that level, in fact, I have an infrared camera that'd be cool to get out for this, but either way, if we could watch that, we would see energy leaving these beakers going out into the atmosphere that's filling this room. Okay, so how quickly does that happen? We will find out. I'll pause again. We'll be back for our 20-minute reading. See you in a few. All right, coming up on our 20-minute reading. And again, that data is just going to go right here. It's just a continuation. This would just be like sand going all the way over there and all the way over there if I had a long enough piece of paper, but it's broken into a couple. And then data-wise, you'll just have it, 15, 20, 25, 30. Then you'll just keep that line going. It's 2 lines of data, one for sand, one for water, going up, then back down. Not 4 different lines. I've seen that mistake get made in the past. All right, here we go. 20-minute reading. We are at 31 for sand, 29 for water. See you again in about 5. 5 this time. Just a moment your time. All right, everybody. Hanging in there. Coming up to our 25-minute reading. In about 15 seconds. I guess I started early this time. All right. Sand is at 26. Water is at 28. We'll see you again for our final reading. All right, before I make it to the last one, what I want to do in the next about 3 minutes is talk about rate of change. When you get down here, you don't have to do it till the end of all 3 experiments, or you could do it as you go, your call. We're going to be doing rate of change problems. Now, you're familiar with rate of change if you've ever heard of the term miles per hour. If you got in the car here and drove, to Watertown or Syracuse or somewhere, and you said, okay, it took me, it was this many miles between the two, and it took me this much time. That's really what a rate of change problem is. And on Route 81, you're probably going 60 miles an hour, right? That's the rate of change. How much did the value change divided by how much did the time change? So you're going to have to do this for all sections of the lab. You're going to have to do it for the sand while it absorbed, the sand while it cooled off, the water while it absorbed, the water while it cooled off. So that's the 4 problems for those 2 beakers as they went up, then went back down. And then the same premise in the next 2 sections of the lab. So I want these to be done where you're going to give me all these values. There really should be 3 parts to your answer. I want to know what the change in value is. I want to know what the change in time is. And then what does that equal? So like, for example, the whole entire experiment for all of them, and maybe if you're clever with the text box and copy and paste, you can do this quickly. Because each section was over 15 minutes, right? We heat it up for 15 minutes, and then we're going to cool off for 15 minutes. So all 12 of these are going to be something over 15 minutes. So what is that something? Well, it's how much did the value change? How much did the sand heat up? Now, really, you're going to have already done all this work. Because if you come back up here to your sand and water, right here where I asked you to do this work, it's going to be that number. You already wrote right here, how much did the sand heat up? That's a star. Right? How much did the sand heat up in the 15 minutes? You told me that. It went from 20 up to something. I don't even remember. So you come down here, and whatever that something is will go right there. Okay? And then equals, and the text box function is probably much neater than this. Equals something. Then you type it in your calculator. Whatever that number is divided by 15 equals some number. And we did this in degrees C. So this should be in degrees C, whatever you're right there. Degrees C, whatever your number is. So when you get a result, like you have with miles per hour, that'd be miles over hours. This result here will be in degrees C per minute. Okay, so again, I don't know if maybe people are clever with copy paste. There's certainly got to be a faster way than I'm doing it right here, right? That should be the format in all of these. I know it feels like a lot, but again, this is a big lab, and we'll have the time. You guys will figure it all out. So that leaves me with about 30 seconds to get to our 30-minute reading here for the sand and the water. About 15 seconds. Thanks for sticking with me. And then we'll do this in a couple of sections, and we'll talk about what this looked like and what to expect for questions and all of that. All right, there we go. Sand down to 22. Water down to 24. 24 and a half if you want to be super accurate. All right, does that sound good? So what we didn't do was think about what this axis over here has to be. Why don't I see what you guys can come up with? The goal would be to use, don't make it like 5, 10, 15, 20, 25, right? Because then your lines are going to be just sitting way down here at the bottom. I believe it's 40 boxes. Count how many boxes, see what your range of data is, and see what do I think a good idea would be over here for the temp in degrees C. What do I want to start with and end with, and what do I want to have each box be worth to make it up to the top? Remember, they have to be the same increment as well. You don't want to say, okay, each box is 1, 1, 1, 1, and then somehow have it skipped to 2s. That's a common mistake while we're all learning graphs. It's critical that each box be worth the same amount as you work your way up. But I'll leave that to you guys to figure that out. If you get stumped, shoot me an email, or if you're here in class, come say hi. We'll figure it out. That should be it for the first section of this lab. 2 more to look forward to. Thanks for sticking with me, guys. We'll catch you soon.